Yo, 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 what's up, everybody? Welcome back. Today we are working on our PNG decoder. And today's topic is just trying to make it not suck. So context is we thought it would be fun to write a PNG decoder. We have gotten to the point where we can decode this pretty little smiley face. We take this, world's stupidest input PNG. We just kind of like opened up color paint and drew a couple lines and exported whatever was default. And when we try to parse this thing, we get to, where is it? Here. This is what we end up with. So why does it look like crap? Well, we've learned a little bit about the PNG file format. This thing is composed of a header, which will tell us kind of like, well, it's composed of like a magic, which says like you can look for these 8 bytes at the start of the file to say that I have a PNG, and then it has a series of blocks. The blocks have like a length and essentially like a name, right? So it has like a header. The header has like defined format. You read that stuff out. You then see a sequence of like data blocks, essentially, where the data blocks, when you kind of like stick them all together, represent one chunk of zlib compressed data, and then you have an end chunk. There are other chunks as well. However, we can ignore them for now because they are not marked as critical chunks in the PNG specification that we're working with. In the data, the header says, how are we going to represent this data, essentially, right? So there's things in there like, am I RGB? Am I grayscaled? Am I RGBA? How many bits should you expect each pixel to be? Are they like 16-bit pixels, 24-bit pixels, etc., etc.? And one of the things that it says is we are going to use this thing called like adaptive filtering, which says instead of just writing out the image pixel by pixel like you normally would, we will say at the beginning of each line of pixels, we will put a number between 1 and 5, I think. Let's see if we can pull up the RFC. PNG RFC. Surely this will get us something. So there's something about like filter algorithms, right? So one of these many things, right? So we might have no filter, which means that we have like the data kind of just there like you would expect. We might be a sub thing, an up thing, average, or paeth, right? Where sub basically is like saying, store the difference between me and the pixel to my left. Up is saying, give me the difference between me and the pixel above me. Average and paeth are doing something I don't know yet. So this is why our thing is broken, is because we do not implement these. If we see 3 or 4, we treat it like none, which is why we're seeing this. Sure, clearly our like output data or input data is leveraging these guys heavily. Now the question is why? Right? Why? I guess actually somebody pointed out a bug in happy hour where it actually could be that they're using up and we are not handling them correctly. That's also quite possible. In fact, we should fix that first. In fact, that should be the first thing we do is fix up filter. What was I saying? Yeah, so these are the filters. So the plan for today is to just try to like kind of work through this thing, try to get as much of this stuff done as we can. And if we get through all of this, we also have to handle some like error checking stuff where like CRC, each block in the PNG has like a CRC at the end of it. We are not calculating those right now, and I don't know how to calculate those. I have to look that up. And if we get through all of that, then we can start looking at like trying to parse more PNGs than just like our one simple case. And if that becomes kind of boring, we can also look at zero allocation decoding. Okay, so that's the plan for today. Let's see. If I remember correctly, you already had debug with filters for every scan line. Yeah, so we have a test case that we've been working with where we kind of like manufacture a gradient like this, and we can like manually specify each scan line ourselves. But we are not doing every single one right now. We were just doing like left and up. Okay, so let's start with fixing the up filters. Somebody pointed out to me yesterday, or not yesterday, a couple hours, like an hour ago, that the way this thing works is you have kind of like decompressed output. And this decompressed output is basically going to look like tag followed by like pix, right? Each of these pixels, if you have like left, this is going to be like if your screen was like entirely yellow, you would have like yellow 0 0 0 0 0 0, right? Everything is no different than yellow. Now, if you have like up 0 0 0 0 0 here, this should reference the previous line, right? So all of these pixels should also turn yellow. And so what we do is as we look at the decompressed output, we kind of like inline just kind of like heal this stuff as we go. So as we look at the stuff, we turn this into yellow, turn this into yellow, turn this into yellow, right, as we go, which means that now this up thing can like reference those yellow pixels essentially. But we do not fix it for the up case. We forgot to do that. And so it could be that our data is actually just stacking ups and we didn't notice. And if that is true, then it should be pretty easy to get this over the line. So I would like to see maybe unsupported filter type is logged here. Can we run this thing and see if it spams unsupported filter type? There are occasional unsupported filter types of paeth, but it does seem like probably the big mistake here is our total mishandling of ups. So let's start there. So we just have to go for each row as we are going through here. We need to say scanline at scanline idx plus b is equal to current. There is no healing to do in the case where there is no previous row. And so this should immediately make us look a lot better. Like immediately. So how do we go? Browse here. Output ppm, refresh. I expected this to look a lot better than it does. So why is that not the case? Let's just make sure that we are writing what we think we're writing. So can we rm output ppm? Oops. And run this thing again. And browse, look at output ppm. Yeah, so we are in fact remaking this thing, unless GwenView is caching something that shouldn't. That's always a possibility. So yeah, it's actually not nearly as good as I thought it would be, which is surprising. If we're seeing up spams, then why is this not working? Well, can we maybe, as soon as we see something that we don't support, can we just break here instead of trying to keep going? If we break here, we might get like some intuition here about why this is the case. If true break. All right. So refresh. Okay, so it looks like, yeah, okay. So this is kind of confusing. It means that all of these lines, it's super broken. That's actually kind of like a fun effect. It's probably because we're specifying the height in this output and we have no like data there, so probably the image library or the image viewer is just like losing its fucking mind. But I would expect this to all work right now. And the fact that it doesn't is very concerning. And I'm realizing now that I'm just a dumbass and we didn't do anything here. Oopsies. That would do it. That would do it. Do we have... My fucking taskbar is broken today. I don't know why it's not showing things that are open, which is very annoying. So I have to like spam alt tab to check if I have this window open already. Oh, and look at that, baby. That's some yellow if I've ever seen it. Okay, so can we go back to not breaking on this case and just see how broken it looks? Maybe it looks like mostly fine. No? It does not look mostly fine. But he's like, we can kind of see like a little crying happy man here. Look at that, he's like a little cry baby, and then he's drooling as well. A little crying, like messed up smiley, drooling smiley face. That's what we've got right now. But it does look like we have fixed the up filter, and it actually seems like the average filter is not being used in here. So probably the first thing to do here is to look at the paeth filter. I don't really know how to pronounce that. Can we... Is this like a word that we can listen to? Usually they give me a little thing inline. Wow, really? Maybe it's not a real word that Google knows about. Can we like does it have like here, this guy? Does it have his like name with the oh, there's none of like the funny letters for us to get pronunciation. So I guess we're screwed. I'm gonna say paeth, and you guys can make fun of me if I'm wrong. That's where we'll land here. Okay, so what is this thing? What is this thing? He says this computes a simple linear function of the 3 neighboring pixels. Well, there's more than 3 neighboring pixels, but he means the 3 that we could look at if we are looking left above and upper left, right? Because we're going left to right, top to bottom. He chooses the predictor as the predictor, the neighboring pixel closest to the computed value. Okay. So does this mean that we have like an index into that thing, right? 0 would maybe be left, 1 would be up, and 2 would be up left or something. X ranges from 0 to the number of bytes representing the scan line minus 1. Okay, from 0 to the number of bytes representing the scan line minus 1. Okay, sure, yeah. So like we're looking at like one line. Raw refers to the data. We've seen raw X before. This is like what byte, what's the value of this thing. Prior refers to the unfiltered bytes, the prior scan line. Okay, so we're looking at unfiltered bytes of the prior scan line. Right, okay, I see. So this is, we have 3 inputs here. It's left, up, left is what they're trying to say here. So we're looking at my value minus one of those. We have to pick one. Okay, which means that we get, how does the predictor choose? This is defined by the following pseudocode. So we have left, up, left. We estimate this by that. Okay. Then we calculate the distances. Okay. And we turn the smallest. Okay. So then in that case, haven't we lost the information of which one we picked? Right? If we need to like go backwards from this thing, how do we know which one won? Because that seems very important. The calculations must be performed exactly without overflow. Arithmetic modulo 256 is to be used only for the final step of subtracting the function result from the target byte value. So this abs, I guess if we're using unsigned arithmetic, we can't use abs here. We have to do like it. We have to pick. We have to pick which one's bigger instead of negating the output because we can't do modulo 256 math. Okay, so reverse the effect of the filter after decompression. So we do the same thing? How is this a... Okay. And then what is this refer to? This is the value we got out, right? Because that's what's stored in the output. And somehow this is like a bidirectional operation. I don't understand how. Because like, what if we have like 0, 50, and 100 as our like 3 possible values? And our value... Oh. No, okay, so we return... Oh, we return the value of the byte, not the difference. So then how do we get the difference? Probably this P thing is doing some bullshit. I see. So they take like the three pixels, they calculate this like P value, and then we don't return the P value. We just return which one won. And then we can recalculate this P value again and pick This, how is this any better? How is this any better than just writing a raw value? I'm kind of missing that. I'm missing that for sure. Because like compression wise, that doesn't really help, right? If we're just storing the actual fucking value that we saw in like the previous row or whatever, why wouldn't we just write it directly? There must be some way that we are like encoding extra information here that I'm not understanding. So when we calculate this thing, oh, we take the value of us minus whichever one is closest. So we're trying to get close to 0 to one of those three things. Okay. But none of these inputs are our pixel, which is interesting. That's very interesting. So how does this get us close to 0? I guess it doesn't. Okay, wait, I think you could maybe there might be some reason that this is good. like and like in some images, this will just compress better than in other images. And so probably what happens is the PNG encoder tries running this and just sees if it gets a better compression result than other things. And there's probably some pattern that it could look for to predict that that would happen. Right? Like if you have in what cases will it pick A? So A plus B minus C. So say we have like small a. So if A is 0 and B and C are the same, P will be 0 and it will pick A. Okay, I think that makes sense. So you have like you're picking the smallest value. Uh, I asked Cody AI about paeth, and he says the filter then stores only the difference between the actual pixel value and the predicted value, since these differences tend to be small numbers. But I'm not really sure what like P is here. This is some like weird thing where like because what's bothering me here is that this is not using the value of our pixel at all, right? He has no idea what value we are trying to encode. So he's picking based off the adjacent 3 pixels, based off of some heuristic that happens to work well. Someone's sent a cheat sheet. Does this guy talk about paeth at all? Like, why? This guy doesn't really say why. Maybe somebody will, though. Does this talk about, like, why? Okay, we can maybe look at this. Can we look at... Can we look at maybe in quotes? Um, this is like a paper. Is this like something that I can just like look at, or do I need to pay money? Fuck. Can I? It's like, can I look it up like this? Does this guy is this gonna have it? Or maybe we can search for oh, here we go. No, this guy's just referencing it. Fuck. God damn it. Cody also says that this approach is particularly effective because natural images have strong pixel-to-pixel correlations. Well, like I understand that. Oh, is this picking which value of A, B, or C are closer to the other values of A, B, or C? It might be that. It might be that it's picking the smallest difference between two. No, because then you would just do A minus B, A minus C. It's something more complex than that. Fuck. How does try Sci-Hub? I don't think I want to like advertise doing that like on stream. I think that might be illegal. But what if Google gives it to us? What if we just type PDF here? uh, I guess we ended up there. Well, I just typed it into Google and we get what we got. Dude, what is this fucking AI bullshit? I don't want to train a fucking AI. Really? None of those look like. With the item scene example, what do you mean the item scene? There's a bear in a car. Am I looking for cars, taxis, bears? What the fuck is this shit? What a fucking garbage. Oh my god, I hate this. Okay. Does he explain why in here? Okay, simple predictive corrective coding filter is derived through empirical and analytical means. Passing a 2D image through this coder in byte serial order yields a highly redundant data stream. Okay. Empirical and analytical means. When used to process this stuff, we end up like, it ends up being like very compressible. But why? Predictor, corrector. Okay. PC coders are a broad family, blah, blah, blah. And this kind of makes sense. You have some sort of input and you're trying to get it into some sort of like shit around zero. Fine. Okay. Yep. So we have, you know, this is the shape that we're looking at. That's true. That makes sense. Is this okay? This is it. Okay. Minimum template considers neighboring values that are adjacent by edge. Blah blah blah. Invariant predictor. Blah blah blah. Empirical data was used to classify the best output of a function of 8 inputs. The data was a large collection of rasters, including digitally top out. So yeah, it just seems like they've kind of like made this shit up based off of looking at pictures. So predictor minus corrector. And may learn based on the true value of the next input. Adjustment most often is weighted linear average for 2D signals. The past state may be represented in a template. So, okay. Then they do some math to basically derive what wins. Or some like they check what wins. Okay, there, here we go. The predictor is B plus C minus A. Why? Why? These constraints are not usually meant for arithmetic precision using Robert's method LR, poor man's Laplacian, which finds the slope along the northwest southeast diagonal. So that's top left and bottom right. They have this shit, and they're like, okay, we get to this predictor. Sure. So he's kind of like leveraging like image kernels in some way, being like unsharp masks have some form of like relation to real world data in some way, shape, or form. Okay. Fourth rule is satisfied by finding the element in the input closest to the trial prediction, thereby forming a final prediction. Analysis shows that 1 to 3 remain invariant because Scalar distance employs the absolute value ambiguity, blah, blah, blah. Okay. I'm not really convinced I understand this in any way, but it seems like hand wavy without really reading this, just skimming. They have done some sort of like empirical evidence gathering that this is like good. And this is like we're essentially applying like an image filter to this thing. And it would maybe be interesting to try to visualize what that is. Yeah, can we do that? We could probably do that pretty easily. Let's maybe whip out Python. And can we get like a Python 3 packages? I think it's pillow to open an image, and then can we get like NumPy? Let's just try to see if we can like understand what a paeth filter looks like on an image. I think that will. It's not a pillow. Fuck. Nix package. Search. Because I want to understand. It's not what I'm looking for. Pillow. It's lowercase. I see. All right. So I don't know if you guys are familiar with the idea of like image kernels. Image kernels, they're pretty cool. The idea is that for each pixel, you multiply these like weights by the pixels around it, right? So this is the identity kernel. You say, I'm looking at this pixel in the middle right now. If I were to add up 0 times all of the things around me and give me the output there, it's like, yeah, that's the exact same. But you can get all sorts of like interesting properties where you start looking at those things like either you like use the inverse of these, right? So here you're saying like, look at my thing times 4 and subtract kind of like the things around me, right? And the idea here is that like when you add up all these things, if you're all the same color, this will even out to 0. But if these things are heavily different, that will, I think, increase the output value. Why? Because you're multiplying the negative. You're adding the negative of that thing. I'm having trouble rationalizing why edge detection works, but like blurring is really obvious, right? You take all the things around me and I just like add them in and stuff, right? So if we're trying to figure out how this paeth filter works, maybe it makes sense to. I guess this isn't really an image kernel actually. I was thinking it was because I initially thought it was because of the shape of this like corner thing. But it's a little bit more. This is the wrong one. It's more involved than that because we have to pick which one of them wins. But I wonder if we just did. So I guess I was hoping that we could just like apply an image kernel to the image, but I think it's not going to work that way. But we can still write a script that applies it. So can we do like a test paeth, visualize paeth py? So we're gonna like import from PIL import image, I think, and then it's like image open smile.ping. Let's just start there. Python 3 viz this thing. Yeah, we're chilling. Then we're gonna want to go like import numpy as numpy, and can we like convert this thing automatically? What's this look like? Okay, cool. We have our image here, and we can go like for y in array, print y. I think that this, or for line. Does this give me what I think it does? Yep. And I guess we kind of want to go for like for y in range 1, maybe 0, to array shape 1, I guess, for x in range 0 array shape 0. What are we doing? We're looking for like array at yx here. He's mad because what? What have we fucked up here? Index 77 is out of bounds for x is 0, size 77. Is this inclusive? Oh, oops, it's 0, 1 here. I got it backwards. My bad. Okay. Cool. That's pixel by pixel. And then I guess we're gonna like apply the input. So we're gonna do like, can you do like, how do you like duplicate numpy array? Repeat each element. No, I wanna like copy numpy array. How do you do this again? It's like clone numpy copy. Okay. Or I guess I want like zeros with this shape. Yeah. And then we can go like array 2 at yx is equal to paeth prediction of the above. Yeah. Yeah. So what is the function here? We need this predictor. So this is def predictor. And here we go left and oopsies. We go back to right. Boom. We have A, B, C. We do this stuff. Take out these like fucked up comments. Boom, 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 boom. And do we need brackets in this language? Probably. Probably. And I think it's like this. And then I think it's elif here. Uh-huh. Okay. Okay. Maybe this deserves an else. Uh-huh. And then the output is the value minus the prediction. So I think we do like for channel in range 0 to this. We have left is going to be array at y x minus 1 c. Up is array at y minus 1 x c, and then up left is this. And then we just have to check. I guess for now, I'm just going to go from 1 on x and y to just make this easier to deal with. And then we can just say this is the value. So this is going to be array y x c is equal to subtract the predictor of left, up, up, left. Let's just kind of see what the fuck we get here. So can we do like image from array 2, save as paeth PNG or something? He's mad because def predictor needs a pull in. And what's he pissed about? We're mad about overflow. It's kind of surprising. I guess we need to do, these are probably like numpy types, which is probably annoying. I guess we probably want to do like int casts here. And then that should fix itself. Okay, and then he's just mad about from array not working the way I think it does. So he's saying that I have 1, 1, 4. Can we like print out array 2 here? What am I looking at? Did I fuck this up somehow? We're seeing floating point numbers, so I want to kind of preserve the data type, I guess. of the other one. Okay. And then here we're seeing a lot of zeros. Can we make fix alpha to 1.0? So we'll do like array to everything 3 is equal to 255. That's mad. I thought that's how this works. I thought that's how it works, but it seems to not be the case. I thought it was. This does seem to be giving me multiple... Yeah, wait, this should be right. What am I fucking missing here? Yeah, it does seem like what I wanted. But here, it's not. Like, I must be getting my indexing wrong? What is, like, the shape of this thing? What have I fucked up? Yeah, Y, X, Z. Y, X, C, right? That makes sense. Are you setting every pixel value channels time? I didn't think so. I thought that this does what I want. God damn it. I guess we can just do this because I don't really know the rule here. We can just do R to Y X 3 is equal to 255. I thought that should do the same thing, but I guess not. I'm quite confused about why some of these are still 0. Am I fucking stupid? What am I missing? Oh, we're missing 1 on each of these, I guess. Which makes this look a lot better. And then how come this doesn't crash? Right? Shouldn't this be crashing somehow? Because, like, x minus 1 might be 0. Oh, but then that becomes -1, and indexing at -1 does something insane. So if... Does Python have ternary operators? Does it? If, else. Yeah, okay. If x is greater than or equal to 1, we do this, else 0. If y is greater than or equal to 1, else 0. If x is greater than or equal to 1 and y is greater... You know what, fuck it. We'll just allow it to look kind of fucked up on the side. I don't really care. We can just have like a little bit wrong. Okay. Can we see what this thing created for us? Fuck. So what's bothering me here is that like we don't see anything that like resembles anything, right? So like what the fuck is this thing doing? What if we like really just kind of crank up the output? Right? Like that's not doing jack shit. And let's just make sure that we do like... Oops. I guess I wasn't really running the code. That would do it, huh? Okay. Yeah, so we're not seeing like any differences in here. Are we seeing anything like at the top edge or anything? No. Can we say like, how can we check if this is like all zeros? Any? True. I guess we want to look at like everything up until the alpha channel because we did kind of intentionally set those. I feel like my indexing here is I do not understand why this doesn't work. This should give me a single number, right? 000. Yes. This should give me the red and green channel. This should give me the red and green channels for 1 pixel. Oh, I see what I'm doing wrong. It's the double slicing thing. We've talked about this many times. It's this. That's how we're supposed to do multi-dimensional indexing. God damn it. So if we go like, give me anything from 0 to 2 or to 3. Is there anything set in any of this? No. So every single value is 0. Every single fucking value is 0. So like, what the fuck is the point in this thing? What if we log the predictors? And like, get rid of this times 100. This is all black as well? Surely not, right? Am I forgetting to return something? Return ABC? Like PA, PB, PC. And ABC. Let's make sure that like we're not like just being like fucking stupid. A, B, and C being all 255 seems pretty fucking bad. This is not what we expect to see in our little smile.png, right? We are expecting to see yellows. Oh, but I guess in the case of this is the yellow, the RNG channels, we're seeing 255s everywhere, which makes sense. Which makes sense. So when we see this stuff, we're seeing, I don't know if this plus is supposed to like, what's supposed to go on this P prediction here? Because this would be 255 plus 255 minus 255, which gives us P of 255. Right? Then we say PA is 0, PB is 0, PC is 0. And then shouldn't we be returning 255s out of this thing? If all of our options are 255? That's a little better, probably. That's better. There we go. We're getting somewhere. I fucked up. So I forgot to set the channel. Okay, so if we do us minus adjacent, we don't see anything, but the predictor here at the very least tells us some interesting information. This tells us that, like, I don't know what this tells us. So smile.ping has this. Paeth.ping has this. So how here am I getting anything but black? I guess because this pixel in the original is not black, probably. Probably. And then again, if we log the difference, y, x, c minus this thing. That's maybe interesting. So what is this looking at? Can we overlay this on the original? If we do like, maybe we open a second one like this and we zoom into the same percentage on both, 800 on this, 800 on this, and then we line them up. So it looks like we're seeing like diagonal boundaries on yellow. We're seeing yellow diagonal boundaries on this side and this side, not here. Okay. Very strange. I don't really know if I understand why, but sure. Diagonal boundaries. Interesting. Okay. I mean, I don't understand the math still, I don't think. But this does, I guess, mean this is something. And I guess if we can go back from it, it's fine. Okay, sure. Let's try to make sure that we can, let's like integrate, I guess. So I guess we'll call this like understanding paeth filter. And then now we'll say we're actually implementing it in our thing. And not that we really understand it, but we can do something. Okay. So when we write out our little tests, could you try to write to array instead of array 2? Why the fuck would I do that? Array 2 is what we're outputting. We shouldn't be changing the input value as we're going. Pretty sure. Pretty sure. Okay, can we say here? We have to be careful here. The filter types that we have to support are going to be, I don't know, some like array of filter types here, and we're gonna be like, we want like none, sub, up, and paeth as we write out the data. Then we're gonna go filter type is going to be filter types at y% filter types len, boom. And I guess this is gonna go here. Okay. And now we should be able to support paeth in here, which is just whatever this math is. So we need to convert this into Zig code this time. So we'll go function paeth predictor. And we have A, B, and C as U8s, I believe, are what's coming in here. Okay. Okay. Then this is equal to take these out, put some consts here. Here we have to be a little bit careful about the abs calculation because there's going to be underflows here. Right, so we have to do like a const diff. I wonder if there's something already in std math for this. Std math difference. Nope. A U8, B U8, and this returns a U8. And we just say blah, blah, blah. If A is greater than B, return A minus B, return B minus A. Okay, so now we can do like difference BA, PA, difference of PB, difference of PC, and like this, like this, like this, and like this. Okay. Sure. So now our paeth predictor thing goes on encoding, we do raw x minus this. Okay, so we say we want the previous row for sure. If there is no previous row, I wonder what we're supposed to do. Extract zeros for the thing up top left and top above and to the left, I guess. Right, so here we have, we still need to do paeth predictor. We just need to do like left is equal to whatever we were doing before. Okay, left is this. Up is 0, and up left is 0. Then we do a paeth predictor of left, up, left. And then our output is just us minus that, I think. Yeah. So it's just in pixel row. Do we have like current already extracted here somewhere? No. So we just do in pixel row at here minus b. Okay. Now in the case where we do have a previous row, it's going to look very similar, except up comes from previous row U8 at the current x position, and then the left is similar to this, except we are using previous row here. Otherwise, it is the same. Okay. And maybe we do it like this. Okay. So can we, if we run this now, we are seeing integer overflows, which is true. So can we do use U16 math everywhere and then do like this and then return int cast of ret to kind of fix that. Differences, can we just replace this with like any type? Use the same type here and here. Okay, so that's working. And then can we see, I think that we're supposed to output the manufactured thing we get. So we like manufacture a PNG, feed it into STB image, read it back, and write that thing out. The idea here is that if we got anything wrong, STB image will output some garbage, right? So if we do like something here, like we inject some form of bug, right? So here we put in like B twice. What we should see is a garbage, like something wrong happen here, right? We do, right? So that's good. That's good that we are seeing kind of like, if we run this, we have paeth outputs here, and STB image is at the very least parsing that correctly. So that means our output here is probably correct. And now we can go into decoding land. and see if we can get the same answer. So we take our manufactured PNG, we run this thing, our thing should fall over. Oh, we're just seeing unsupported filter type path, right? Makes sense. And now, theoretically, we just undo this thing. And they're saying we undo it with this. Right? So we get the value. This is the value in the array. It looks like we have to do kind of something similar that we were doing for the up. So surely there's deduplication to be done here. But fix me dedupe with up. We'll kind of figure that out as we go. Okay. So this is now up. This is current. We need left here is going to be whatever the fuck we did here. Uh-huh. And then we need to figure out what up left means. Presumably we are supposed to do something here as well. But we can just panic here instead. Nice. Because I don't know what I want to do yet. Okay, so then we have const up left is going to be this again, I guess. But we're going to look at P here instead. What is current index? We have like, this is called scanline index here. Okay. And then we just say that this is the path val. And then we say that we heal this thing as here. So first of all, that subtraction on right should have been modulo 256. So this would be like this. Okay. And then we need to add that thing back. I guess. I don't know. Seems reasonable to me. What happens if we do that? Does our output look okay if we look at our output ppm? I'm not quite convinced. Right, there's some sort of like bullshit happening here. It looks like there's like, I can't tell if it's supposed, if there's like duplicate lines here or not. Can we do like, can we just go fucking ham on paths? Right, so if we look at test manufactured, that's what this thing looks like. I guess we need the first line to be none. So can we just do like just something like this? Like, okay, so this is what we get. This is what the thing looks like. Then when we parse it, we get this, right? So we're clearly doing something wrong. Very clearly doing something wrong. I don't know what. I do not know what, but like clearly we're getting like darker as we go down when we shouldn't. Or at least we're not getting, yeah, we are seeing like straight up like this is darker than this. It has to be. Or at least it's darker than the thing to the left. Okay, so what have we done wrong here? What have we done wrong here? This thing says calculations within the paeth predictor function must be performed exactly without overflow. Arithmetic modulo 256 is to only be used for the final step. I guess we could use int16 math here instead of right, we could do this and then do abs e minus a like this. Okay, and then this is still broken, but the fact that this is correct, like what STB image reads from our thing, is an indication that the bug is on the parsing side. Right, so let's make sure that we got this right. So left, we say if we cannot look left, we get a 0. Up, we look at that thing. It's always there. Up left, we try to look at the previous line to the left, otherwise 0. And the value we get is at here. Seems pretty straightforward to me. Paeth plus left, up, up, left. Okay. So I don't really understand why it feels like we're just doing the right thing. For all x is less than 0, assume raw x equals 0 and prior x equals 0. On the first scan line of image out of pass, assume prior x equals 0 for all x. Yeah, that's what we've done. The tiebreak order is pixel left, pixel above, pixel the upper left. Calculations within paeth predictor function must be performed exactly without overflow, which seems correct. I mean, the fact that we have the, like, our paeth predictor function has to be correct, right? Because what STB image parses looks right to me. Unless we're stacking errors, but that doesn't seem extremely likely to me. What were you returning the paeth predictor? Here we are saying that we have like this if else chain to construct the value of ret, and then we're just like incasting that thing back to a U8. And then we're doing all those things like I16 arithmetic. Let's just double check this if statement again. So if PA is less than PB and PA is less than or equal to PC, yep, return A. Else if PB is less than or equal to PC, return B. Else return C. Seems reasonable to me. Seems reasonable. I just want to look at the output again to see if I can infer anything. Yes, we're seeing a reset every once in a while. So I assume here we could do something that's like filter type paeth times 9999, right? Like, let's just go fucking crazy here. Let's try to make sure that there's no resets. And here we can get a pretty good clue about what's happening, right? We're basically seeing that the previous, we're getting no difference from the previous line when we should be, right? And again, we can prove here that, as assuming that we're writing test manufactured.ppm, I'm pretty sure we are. I'm pretty sure. Yeah, this thing is back. Yeah, so this is totally fine. And yeah, our parsing is just like very, very wrong. Specifically, our stacking of parsing. So where is scanline coming from here? Scanline is the decompressed data from start to end. Okay. And I wonder if we're not supposed to heal in this case. Prev plus current. Oh, this is on up, sorry. Okay, previous row from the decompressed data from the start to the end. Is that what this is supposed to be? Size? Yeah, stride. We go here, we increment by 4 pixels every time, which is the correct stride of a pixel. In this particular image, did we make a mistake here? If scanline index is greater than or equal to bytes per pixel, we look to the left. Up, we always have valid here. Up left is we do the same thing. We do what we did for left, but we do it for the previous line. And then our value is this thing. Is it possible that our inputs to this thing are wrong? Left, up, up, left. And that makes sense because our thing was supposed to be our value minus this. So adding this back to whatever we got makes a lot of sense. It feels like we are not correctly representing the previous line. That's kind of how it feels. Does up have a value in the first line? Yes, because we are only in this case if we hit the previous row, and we've made sure that the first line of the image is valid in our output. Like our first line does not use the paeth filter. The first line uses filter none, and then all of the future lines use the paeth predictor. Hear me out. Can we just look at like what the fuck is in that shit? Like if we don't undo anything, like what are we looking at here? If we look at output ppm, a lot of zeros essentially. Yeah, so it looks to me what's happening is he's always picking the up value, right? And then he is kind of just saying that his difference is 0. So can we look at like std debug print paeth val is this. And let's just start here and see what we get. Right, so we're just getting a slamma-jammas of a lot of zeros with an occasional 5. Okay, wait, so that makes sense actually. So the 5 is trying to say that I am kind of increasing in green value, right? So we're saying like RGB, right? Then we are seeing that like a bunch of zeros, which kind of indicates to me that we're supposed to be like mixing the difference from the thing above us and to the left of us, right? That would kind of make sense. That would kind of make sense, right? It's saying like A plus B minus C. We're saying like, yeah, there must be some sort of mixing of the change to the left and above, right? And so like as we move right across this gradient, we should be seeing basically us taking the change of like B minus C, right? The top, where as we go across to the right, P grows with the movement to the right because it's taking like the difference between the upper left and the left, and sorry, the upper left and above. But it's also taking the change to the thing on the left, and that thing on the left is like moving up as well. So I can kind of see how this could encode this information that we're looking for. The Huffman coded Huffman codes were the bane of my existence whenever the PNG decoder. Fuck, I forgot to set the title again. We're not working on that anymore. We were working on that earlier. But I hate it when I forget to change the title. Does up have a value on the first line? I think that I answered that already. I think so. So what are we doing wrong here? Can we look at the paeth predictor? Left, up, left. What am I doing wrong here? What's he mad about? Oh, I didn't save. That would do it. Okay, so when we first see our path val of 5, can we like maybe give me a second, let me think. Let me think. I would like to I don't really have a good answer here. Can we like I want to look at the top of the file, not the bottom. Okay. So at the very top, we are on the second row here, and we see red, green, blue. Now in this case, our predictor is 0, right, for green. And so, right, here we go. So we're seeing on the first column the correct behavior, but then on the second column, this is where it's falling over. So we have RGB, RGB. So this is getting a value of 2 for green. So it looks like our predictors RGBR. This seems like a problem. The predictor, here's the problem. Here he's picking 0 instead of looking to the left for the green value. So the green value is never incrementing, which again that is what we're seeing. But why? Why is the green value supposed to be picked? It must mean that we're doing something very, very subtly wrong here. So can we look at this again? The calculations within paeth predictor function must be performed exactly, without overflow. Arithmetic module 256 is to be used only for the final step of subtracting the function result from the target byte value. Note that the order in which ties are broken is critical. Okay, for all is x less than 0, CM0, blah, blah, blah. Computed mod 256 were raw and prior referred to bytes already decoded. Exactly the same as the paeth predictor is used by both the encoder and decoder. What about, maybe it's like on image right? Again though, the fact that the STB image decodes us correctly really points to this working okay. Unless I'm making a mistake, where are we fucking writing this thing out to? Am I just like fucking stupid? Write PNG is going to test manufacturer.png. So test manufacturer.png is being written like now, right? It's November 8th. Yep, at 3:11. Yep. So that is in fact happening. And then we are supposed to be taking that thing that we just wrote out and we are reading it with SDB on, running it back out over here. So all of that is sane, which really, really, really points to this. Really points to decoder. But I'm just not seeing. I wonder if it's like. It really feels to me like our prediction is wrong. I just want to be very, very, very sure that this is the same. X raw prior prior. Raw prior prior. And we are healing in this. There is no up or left filters to worry about. It is only paeth filters. Only. And we are healing the previous line. Are you sampling from raw data instead of decoded data? I don't think so, because I think that when we sample here, we heal what is in the scan line. So the scan line comes from decompressed data after zlib decompression, right? The previous row comes from the decompressed data from the scanline range again, but he just does like a little trick here where he says start minus stride to start, so that makes sense. Then we are iterating this thing at scanline index 1 onwards, right? So we're skipping the filter byte. Yeah, I'm just not seeing it. Left is scanline index. I wonder if this is wrong, this if statement. Because scanline index starts at 1, which kind of means this needs to be +1 here. I wonder if that's like that has like mega effects on this thing. Okay. I mean, it's clearly wrong. Like pretty clearly wrong, but at least we've done something. So let me think about this. So scanline index needs to, if it's greater than bytes per pixel, this should do the same thing that we just saw. Because it's tricky because the scan line and the pixel positions are slightly confusing. Very slightly confusing. But it does seem like this is having like mega effects. So let's make sure that we did it right over here as well. Again, though, we have to assume that the right side is correct because we have seen that the right size is reasonable. Can we do like... Oh my god, I'm a dumbass. Scanline index, we need to add B for all of these. Oh, what a simple bug. What a simple bug. Because we're iterating within color channels here, and we forgot to iterate within color channels here and here. It's a very subtle bug. Why is this changing behavior on refresh? That doesn't seem good at all. Oh, are we still breaking out early from the test we did earlier? We go height. Have we fucked something up here? I don't think so. I mean, but pretty clearly this thing is not rendering the whole image. Are we breaking out of this loop anywhere? No. Weird. Very strange. What the fuck? So we're going for each. I mean, okay, again, we need to look at the test manufactured. This is the right size, which means that the data that we have in the PNG must be correct, which means that it must be the final write that's doing something wrong. There was a thing that you changed before you figured out the bug. Yeah, it was that we're going color by color here, RGBA, and we forgot to adjust which channel we were looking at, which was a mistake. I think that this still is supposed to be +1, actually. I'm not going to lie. Not that I think that that's going to change the bug that we're seeing right now. I wonder if this has always been broken. It could just be that refreshing this thing doesn't work. No, that's pretty fucking fucked. I don't understand how we fucked this up so bad. Because I remember we did something earlier where we like exited early when we saw the top of the eyeballs, but I don't think we're doing that now. Scanline index plus equals 4. Well, this is like that. It's fine. Each row is looking kind of reasonable. So we must just be exiting early somehow. Width, height. We can like look at output ppm here. We do see 100 by 50. Hex, can we do like do.hs output ppm? Oh, maybe the alpha? No, there's no value here. Tail-c, or how do we count how large this thing is? So 2698 divided by 4 divided by 50. Yeah, I mean, that is wrong. So what are we not running out here? Hold on. 2698 divided by 100. Even that's too small. Even that's too small. Dude, I'm gonna lose my knife. Std debug print. Why is this value? I'm sure it's just something stupid. It's always something stupid. So we are getting all the way to the maximum Y. Here we should be writing 3, oopsies, for paeth. We should be writing 3 bytes per 4 bytes here. I feel like I'm losing my mind. Scanline index here. So we are getting all the way to 397, which is a full line. Are we just not flushing the file or something? This is just a file with a writer. Like, surely we're not doing something stupid like that. Because this hasn't been a problem until right now. How confusing. can we count how many bytes we're writing? Like, surely I'm gonna lose my mind, but we have to debug this somehow. We have to. Right, so let's just kind of wrote this much. So we wrote this many bytes. That's a different answer than we got last time. 4700 divided by 100 divided by 4. Oh, it's divided by 401 for scan line size, I guess what we're trying to do. 14700 minus 4 divided by 401. Yeah, we're supposed to be seeing this. Decompress size. Oh, but it's divided by 3, I guess? $14700 bytes written is only set on paeth output. Divided by 3. Okay, that's 49,000 bytes written. 49,000 pixels written. Divided by 50. 98 rows. Oh, sure. So because the first row doesn't count. That feels almost right. Does it still look fucked up? I can't justify what was wrong. I'm not going to lie. This is correct now. I do not understand why tracking the bytes written has any effect whatsoever, right? Surely this is the same. Right? Am I stupid? I feel like I'm losing my fucking mind. I don't understand, like, it's working now, but it's really bothering me that I don't understand why it wasn't working before. Really bothering me. Because you're closing the file now? Could be. I really didn't think that should matter. Kind of thought that it handles that by itself. Yeah, that's very strange. Very strange. That doesn't seem to be it either. I'm not gonna lie, I'm confused as all hell. Confused as all hell. But that does seem to be it. We have like a functional output now, which is pretty sick. I wish I was paying a little bit more attention. I don't understand where we went wrong there, but I guess that is how it is sometimes. I'm going to assume that maybe we'll just make the assumption that it was some sort of like intermediate bug where we had to close the file, but that seems unlikely to me. Because I was under the impression that like Linux automatically handled that shit for you. I wonder if it's possible that on create file is our default creation flags. We were supposed to truncate this, so I don't really see a problem there either. All right. I don't know, man. I don't have a good answer, but whatever. That's good enough. Okay, let's just stop thinking about it. And let's see if our smile test works correctly now. That's all I want to see here. Let's fucking go, baby. Let's go. We have successfully decoded our test PNG, which is pretty sick. Pretty sick. I don't really understand. It seems like this idea of like the paeth filter was not complex, but it still took us an hour and a half. So I guess that's fine. We'll call it here. I think the rest of this stuff I want to do offline. There's a lot of cleanup to be done. A lot of cleanup. But not cleanup that can be done easily in half an hour, I don't think. So things that we have to cover. There's tons and tons and tons of duplication in here, right? Like this is just like shit code. I would like to try to get this PNG decoder working with no allocations. So I would like to take a stab at that. I think that we can like kind of buffer just like one, like it seems like we've learned at this point that as we decode, we only need to look at the previous line and our current line. So we could probably make a PNG decoder that just buffers the last two lines and then could like run on the fly. It'd be kind of cool to like pull from the zlib data, like lazily pull from it and kind of like do this whole thing as like a streaming thing that uses like very little memory. That'd be kind of fun. But I think all of that I will probably do in happy hour because I don't think it's worth a stream. I think we will kind of probably the next thing we're gonna do is start trying to work on an image editor. I think that's probably what's coming up next. So maybe we take a day off tomorrow and come back Saturday or Sunday with that. So thank you for watching, guys. If you like what you saw, we stream most days at 12:30 o'clock or 12:30 Pacific time to 4 o'clock Pacific time. It is 3:30 Pacific time now, so anywhere between 3 hours ago now is when you just got to see us live. I guess 3 hours ago to half an hour from now. If you're watching on YouTube, there's a Twitch link in the YouTube description. You can swing by and say hi if you want to. If you're watching on Twitch, there's a YouTube link in the Twitch description where you can see archives of the previous work. There's a GitHub link in the Twitch description. I will put this up there at some point. I have some cleanup to do. Don't forget to like and subscribe. Twitch Prime, you know, classic streamer stuff. Yeah, we'll catch you on the next one. YouTube, goodbye, and Twitch, let's find someone to read.